Hi, I'm Danny Shapiro. I'm the Senior Director of Automotive at NVIDIA, and we're at the kickoff to CES. We just completed our press conference where we introduced the new Tegra K1. It's a super chip. It has 192 cores. So it's great for doing a lot of different types of high-end processing, and in particular, in the automotive space, we've introduced the Tegra K1 Visual Computing Module, or VCM. So what we're showing here is how all this computing power can actually do a lot of amazing things in the car. One example here is using photorealistic materials to render an instrument cluster or an infotainment system. The demonstration here is showing, again, a variety of different materials: carbon fiber, brushed metals, rubber, plastics, car paint, as photorealistic materials in the cluster. We have a configurator tool here, so I can go in and make changes. I can see the effect of those changes, pick different materials, and then again see how the changes I make on the configurator would appear in my car instrument cluster. We're also showing how designers can integrate the whole interior design of the car, again our traditional business using our Quadro GPUs in workstations, and merge that with what's going on in the cluster and infotainment system. So using a tool called RTT Delta Gen, which is used by most automakers, they can build a full three-dimensional photorealistic model of the interior of the vehicles, and then we're able to take this kind of instrument cluster content and actually merge it straight into that design so that they get a real sense of what the actual car interior will look like, both the physical materials and the simulated CG materials. And then we're also using the Tegra K1 for advanced computing, what's called computer vision. And this is helping a whole new field in automotive called ADAS, or it stands for Advanced Driver Assistance Systems. So ADAS is appearing in cars in things like pedestrian detection, blind spot monitoring, lane departure warnings. And the way these systems work is a variety of different kinds of sensors, from radar to laser scanners to cameras, are looking to see what's going on around the car. And then a processor like a Tegra K1 with its 192 cores is perfectly suited to take that data in and be able to then analyze the situation and determine whether or not a hazard exists, or to alert the driver that there's a car in their blind spot, or they might be straying out of the lane. And then alert the driver to those hazards, or potentially even take over control of the vehicle, correct the steering, or brake the vehicle to avoid an accident. That's, again, thanks to the processing power of something like Tegra K1.